Welcome to the Public Health Data Workshop, presented by Welcome to the Public Health Data Workshop, presented by Harris County Public Health, building a healthy community, and Houston Health Department, promoting and protecting the health and social well-being of Houstonians. Hosted by the Houston ION, the nucleus for innovation, inclusion, collaboration, and exploration. Harris County Public Health and Houston Health Department are excited to champion the CDC Data Modernization Initiative, modernizing our data infrastructure to quickly recognize and mitigate threats to public health. We are striving to create partnerships that provide enhanced and more precise data to better serve individuals and communities. Join us today as we explore and get hands-on learning practical data applications for the changing health landscape ahead.
Coming loud and clear. There's another channel is the
All right. All right. Good afternoon, everyone. Sorry for the delay. It was technical issues. So I'm Ishita Sharma. I'm working as a data scientist at University of Houston, HPDSI. Still learning to be a data scientist, so that will be my short intro. But yeah, I'm working with a lot of data. That is the coolest thing. So this workshop is basically about the data science techniques which you generally use when you begin with the data analysis. For example, the different steps which you will be following, like the first step when you follow is the data extraction. Now, data extraction, data collection, which you can say, and then finally cleaning up of the data. And then, of course, data subsetting, it does come in data cleaning and everything. And then final is creation of the data models, which is basically the prediction models or the models which you create when you are working. I mean, for example, in this case, it's a classification data set which I'm using. It's basically trying to classify the different classes of the field depending on the different features. So it's classifying into normal, and there are two other classes. We'll go through the data. Well, my point is that if we go to our, I do not have. All right, if we go to our, so today's agenda is basically, I'll be letting you know about the different libraries which we are going to import for doing the project and how we can load the data. Obviously, in this case, our data is already, I already have a file, and I guess the file is also shared with you, right? It's a CSV file, so we will not be doing any data extraction, which can be done using various ways like API or other things, which I'm not going to talk about. We already have this, so we're going to import it using our libraries. And then we will be doing data pre-processing, which is basically the next step. The data pre-processing does involve various steps, which is like cleaning up of the data, data subsetting, or data subsetting means which columns you're going to use, which columns you're going to reject, or maybe the subset of the data which you're going to use to address your the issue or the business problem which you are going to address. And then the data filtering, which is like filtering off the different rows. So data analysis, well, data analysis can be described in two ways. That is basically cleaning up of the data also comes in data analysis, visualizing of the data set, and then comes the model building. Model building is the one which requires your knowledge, plus does require the least amount of work. I guess the first few steps, which is data cleaning, data pre-processing, is the one where you spend the maximum time.
Can you pause for a minute?
Sorry.
If you might go into stream and sharing your presentation, you'll have to switch between the two.
Okay. Stop sharing and reshare?
Yeah.
Okay.
So open up Explorer.
Okay.
Share again and choose what you're supposed to do.
So I cannot switch between the two. I've chosen window anyway. All right, thank you. So yeah, the last will be the conclusion. So I'm going to normally for R Studio is the one which we use. I would say R is a language which does has an environment for itself, but R Studio is basically an integrated development environment, which is it allows you to easily load libraries or install packages and do all the other stuff which we're going to do. And also, R Studio has come up with the R Cloud. R Cloud is basically it is having the same R Cloud setup. The good thing is that for now it is free till August 2022 because they just released. So they're just letting people to try this out. And the key features are that it helps you instant analysis, which is like instant analysis is basically some of the packages they're already preloaded, so you installed, I would say. So you have to just load the libraries. Sharing of the project, so you can work in collaboration with your partners or your organization, wherever. Private collabs does work, so it allows a lot of people, as in people in a restricted group, to work with you. And also it does have an R Studio community inbuilt itself. So let me share that. Okay, so this is, if you see on the left-hand side, this is what you can pull up. Your workspace will be, when you're going to pull this up, so your workspace will be completely blank. You can create the new workspace from here. And these are the different learning guides or the R Studio community, which I'm talking about. Otherwise, also the R Studio community can be available, but you have to Google it on the side. But here you can pull it up from the from the left-hand side. And obviously you can, if you're interested in doing more than 75 projects, then you have to look for the plans and everything. Okay, let me quickly introduce you with, so just a quick question. I do not have a poll for the virtual students, but yeah, just a quick question that how many of you are familiar with R Studio? Okay, almost everyone. Well then, I'll just quickly introduce. So this is, I guess, your workspace, since you're already familiar. This is where you write your script. And I would recommend always write your script over here. And this is your console, which comes in again. Okay, it's not coming still.
So each time you go between one, you might just stop sharing.
Okay. All right.
And should we have a when you because you know her data.
Between the entire screen.
Now it works.
Okay, now try it.
Is it good? All right, thank you. So yeah, it's already divided in 3 parts: the console, the terminal, and the charts. Of course, the terminal, depending on your, by default, R Studio has the terminal, but the terminal is basically the command prompt from your Windows, or the terminal itself from your Mac or Linux, whatever your operating system you're going to use. And on the right-hand side are the 2 windows, which is basically your, it has like lots of parts. So in this, the last part is where you can see all your plots. But having said that, there are lots of technologies. I would say the packages like the Shiny web app, where you can export your data, export your plots, and you can just see it using, it's just like a web app. And also this is basically, it's the environment, the packages which you're going to install all the variables which you're going to create, and all the connections, and of course the tutorial is also mentioned. All right, just a quick way to start is for those who are not really familiar with it. Maximum of my class is familiar, but yeah. So you have to click on the new file, and you'll have a couple of different options from here. So first, usually we start with R script, which is the one which I'm going to use, and then comes the R notebook. The R notebook is, again, R notebook and R markdown are the ways where you can report your findings, as in the script. And then the Shiny web app and the Flubber API, all these are the web apps for your plots, etc., to display them. So you don't have to, the plus point is that in Shiny web app, you do not have to be familiar with HTML, CSS, and all that stuff. They have already pre-written the APIs. You just have to insert the data set. So I did not include anything in this workshop because it's got to be otherwise 4 hours workshop. So, but yeah, I just wanted to mention, so if you're using it, you can use it. And also there are other languages which are present. Okay, now I have to reshare my screen if I go here. No. Okay. All right, I've included the access link here. If you'll be able to click it to use the RStudio, but the way how to use it, you need to create an account. Again, logging in, and first, if you already have it, logging in, then sign up. If you're not having it, do you already have the file with you, the CSV file? Yeah. Okay. The fetal.csv file. So we're going to use this file. I am not from the background of a medical site, so please disregard the results because it's not in consultation with any of the doctors or the physicians or any of the researchers on the side of the medical. I'm a computer scientist, so I'm going to tell you from that perspective. But I did do this data so that you can get familiar with the ways in data science using the health data set. Well, this is the data set, which is basically, it is having the 2026 records, which is usually the data set is bigger than this, but of course, for the training purposes, taken a lesser data set. Now, in this data set, we already are having, so these are the different columns which we are having, and these are divided into features and target. Obviously, when you're going to pull up your fetal health.csv, it's going to come in a spreadsheet, or if you're, it's a .csv file. So if you're going to open it in an Excel sheet also, it's going to come in different columns. So how to recognize those, first of all, how to recognize what will be your target, which is what you're going to create, or what you're going to predict. That is, what you're going to predict as a normal class suspect or the pathological class. So it really, you have to recognize this based on the features. So your prediction classes will be your target, and these will be the features, which will be the columns. Well, the step one always. So if you look on the figure on the left-hand side, which tells you different steps you follow when you do the data science project. First of all, again, importing of your data set, which is very important. Based on your importing of the data set, before that, you need to know what is your business problem. or what is your research problem, what you're trying to find out. So after that, you're going to work on the tidying of the data set, or the transformation or the reshaping of the data set if required. Then finally visualizing and creating the model. So this is this cycle keeps on repeating depending on what subsets you're working with and what is your requirement. And then finally, the main step is communicating the data set, as in, again, creating reports in Tableau or Power BI, whichever tool you use. Okay, so first step, which is EDA, exploratory data analysis is also known as EDA. Now, it begins by asking some quality questions. Obviously, just keep in mind this very thought that there is no routine statistical questions, only questionable statistical routine. Statistical routine. So basically, whenever you're looking at the data set, you know that what you're going to find, but you don't directly know that, but you do have the idea what you're going to find, what will be your aim. So always, and yeah, before, always make sure that you have proper data compliance. That is, the data is available to you, all those NDA agreements. So yeah, and always look at the metadata. So what is metadata is basically, again, looking at the data dictionary, looking the data agreements, and looking the sources of the data, etc. So what the data is about now, this data is basically, it contains features which are extracted from CTG exam. Sorry, I'm not very familiar with the medical terms, so please pardon my pronunciation and everything. So that here basically we are trying to create the techniques to access the, to assess the fetal health, such as checking the fetal heart rate, uterine contractions, fetal movements, and there are many more. So these are the columns which are present in our data set. So with this columns, we're going to with these columns, keeping in mind, we're going to classify that into different classes, which is normal, normal, suspect, and pathological. So after this is what you have learned about the data. Then the second method, or the second step, I would say, it comes, what is the dimension of the data? Now, in this case, dimension is basically the how many rows in the columns you're having. Head and tail is basically, it's going to tell you about the first 6 rows. In R, it always tells you first 6 rows. This is, yeah, so head, if you use the head method, head function, it's going to tell you the first 6 rows of your data, and the tail method, it's going to tell you the last 6 rows in the column of your data. And otherwise, you can also use the structure, which is structure. STR stands for the structure, which tells you the main structure of your data set. And the last is what it can answer. So basically, that's the main target for now. It's that the data set can be used to create a multi-class model to classify CTG into 3 health states. Okay, so with this, I'm gonna pull my RStudio. Okay, so initially, in order to start with the EDA, again, it's a good practice if you're using set.seed. Now, set.seed is used so that if you're having any dynamic results, like if you're using any functions which could produce any dynamic results, it will remain constant for at least this much of time. So that's what the meaning of this function is. And the first function which I used is basically, it's gonna ignore the warnings. which you're already aware of. So basically, if you are not aware, if you're working for the first time on the project, I would not recommend to use this function. But if you know that these are some of the warnings which you can ignore, which you do not want in your data set, you can use this function. So your first step will always be your installing of the packages. So whenever you're going to install the packages, now there are two different ways you can install the packages. You can do hard coding, which is, again, install.packages. So this is the one, install.packages. Always make sure that you use the quotation mark. So you can use the double quotes or single quotes, whatever, disregard the spellings. It should be the packages right here. You have to write the packages always in a quote. That should be your first step, otherwise it's going to throw error. Now, the tidyverse is one of the R packages, which is used mainly for all kind of data cleaning, data pre-processing. And it's a library or the package, which has a couple of different packages under it. So basically it is having deployer package when you're going to install this. So if you're going to install this, I have already installed it. So let me see if I can install it again. No. Okay, I already. Well, I already have it, but you're going to see different, when you're going to install it first, you're going to see different packages which are covered. So basically there will be deployer package, ggplot package, the tidyr package, which will be covered. So this is, you can just take a note that tidyverse is the main library which is used for cleaning processes or EDA processes. Again, after installing the packages, then second step comes the loading of the package. That is, you have to use the library function. Library function is basically a library and the parentheses. So that's what the function is. These are already written in the whole R language. The whole R language is written in C. The script behind, well, that's not concerned here. So you can just call the functions, which is library, and then you can name your package, which is which you would like to load. So, for example, in this case, the tidyverse or the deploy. This is the deployer package, which is also the part of the tidyverse package. Again, I forgot to let you know, there is also another way to install packages from your right-hand side, from the GUI, which is graphical user interface. You can install the packages from here also, so you don't have to do all the install packages and library, etc. So you can search your package over here, for example, tidyverse or deployer or Caret, whichever package you're gonna install. You can write the search from here, and then you can click on the install, and also you can update your packages which are already installed. All right, after this, so in order to get the first birds or first few steps to get the bird's eye view or the overview of your data set is using the head method, which is head function, I would say again. Now this is, you have already imported the data set. Now importing of the data set is, again, on the right hand side, this is using the GUI. On the right-hand side, we have the import data set. You can use from text, and you can see the file, which is fetal. I already have it, so I'm not going to. So you can open it from here. So this will help you import the data set from the GUI. Otherwise, you can also use all the PD the coding method, which is you can import using the coding method, which is read. So you can name it. So this is basically data one. I will name it. And this is equal sign, or there is also a traditional sign, which is less than arrow sign, which you can use. So, but for simpler purposes, they have also included the equal sign, so you can use that. It's easier. Read.csv if it's a CSV file. So right away when you're gonna write read, it's gonna prompt you the different file extensions which you can import. So for example, in our case, we have a CSV file, so you can import the CSV file. So if I click on this, well, it's open on the right-hand side. So read.csv, your file name, which is fetal health, which is right there again. Sorry, any questions?
Yeah, I don't see how to import this back. When I go to file and then import data set, and then I click on the from text base, then I get this screen.
Okay, so did you download the data?
Yeah, that's on my computer. Oh, I had to upload it into here first. Oh, okay. Okay.
Sorry, that's the part of the R Studio.
Yeah, you know.
Sorry, I'll just include this again. So in case of R Studio, you might have to upload it because R Studio Cloud, you might have to upload the data set, which is, so if you go on the Files tab, so you see the upload option. I already have it here, but I uploaded from the computer. I mean, in this case, from this computer. So wherever your file, you can choose wherever your file location is, wherever your file is present. So after uploading, it will be visible in your current working directory, which is your current project directory. With this, you have uploaded the data. So you can use that. So that means you can use it right away. You don't have to import the data using this read.csv function. You just have to, you can use it right away. You can use the function, rather after doing that, you can use the function. But make sure that it's in the same project library. That is all the files, that is your script.r script and your .csv file should be in the same project. So you can use the view function to see your data. So another tab will be open on your right hand side. This is what your data looks like. So basically it is having so it's currently showing 1 through 16 rows, and these are the particular total entries. So basically 2,126 rows, and there are 22 columns. So you can, this is basically, you can look at the GUI or just in the, I mean, Excel format, you can say. That was, again, that was using your upload option and then import dataset option from your text file. So you will be able to import the dataset using the GUI. Otherwise, you can easily, from using this function, you have to give the whole path of your data set. That is where your file is present. For example, if you're using your Windows, so if your file is present in this C directory or in documents, then you have to give the whole location of that particular file. Then you'll be able to upload the data set from that file, from that location. So basically, if I roughly write it, then it would be this tittle sign. You can use the tittle sign where your this means your home directory, and now the folder where your file is present. Folder as in this will be, for example, this will be your documents or your Windows C, wherever your file is present, and then the name of the file. This is the way you can use to import using the coding method. Well, it's easier to use the GUI because it's just you have to click and then you have to choose the file. Again, this is the head, which just helps you to show the first six rows of your data set. Again, in case of head method, using the view function, you can use, you can see all of your rows, but these are different helper functions which they have created. So by default, it's going to show you all 6 rows. Otherwise, if you want to see like first 10 rows or first 20 rows, then you have to give the name of the rows, that is 10 in this case, or 20, or whatever number you want to see. And again, this dim is the function which helps you look at the dimension of your data set. That is the rows and the number of rows and the columns. So in this case, we know that these are the different number of rows. So by default, the first will be the number of rows and the second will be the number of columns. And the structure is, so the next function is the structure function, which basically tells you what are the different columns which are present in case of your data set. So the first column are the different columns which are present. Then the data type of each and every column, that is data type, what for example, the baseline dot value, what it is, like number. It's so all of the data set is in numeric, so it's a short form of numeric data type. So all of this will be numeric, contains all the integer plus the real numbers. So all the decimals and all complex numbers, they're all included in numeric data type. So all of this is the numeric. And the last one, which is the fetal health, which if you remember that we have set it as the target, which is always going to be our target in this case. Now it has different numbers, that is different levels which are present, that is 2, 1, 2, 3. So those are different classes, which how you will get to know of those, it's by looking at your data dictionary that or your data set. So if you see on the last column, this is the whole, if you see the data, you will see that the whole column is subdivided, or it's categorized. It's a you can say a categorical column, that is 1, 2, 3. Only the 3 values are present, and you also know this from your data dictionary or your data documents metadata, which is present with you. In this case, the first, the class 1, which is the normal class, it's denoted by the digit 1. And the second, which is the suspect class, is denoted by the digit 2. And the last class, pathological, it's denoted by digit 3. So when you might have imported the data set, you might Okay, you might have got like a number over here instead of factor. Can anyone confirm? Maybe virtually, or if you have imported the data set. Okay. Well, so if you run this function over here, which is the structure function, structure, and the name of your data set, you will be able to see the number data type over here instead of number as a numeric data type instead of the factor data type. Well, it's okay. Well, yeah, so the whole point is why it's converted into a factor data type is, again, it's having only the 3 levels, and this is the target column. So it's having 3 levels as in 3 categories. That is 1, 2, 3. So factor is another data type, or data type or the helper function in case of R, which you can use to classify or categorize the column, which is a categorical column. So instead of numerical can be a continuous value, for example, like this. For example, like this. This can be, so numeric can be continuous, for example, 0.003, something like this, or it can be a discrete value, which is 126, 198, 170, something like this. But this, if you see, you will see the pattern that is 1, 2, 3 only. So this can be converted into a categorical data type, which is the factor, which is necessary. You'll realize why it is necessary when we'll create the model. Okay, so again, this is the alternate method which you can use. Now the glimpse function is, again, it's going to give all the information which we saw so far. So number of columns, number of columns, the name of the columns, and the data type and what data they actually contain. But this is a part of the Gapminder package, which you might have to install before using this function. Let me just quickly. Also, just so you know that the ways to check for the packages or use the helper guide, which is present in R, you have to use the question mark and the name of the package. Hopefully that's the spellings are correct. Okay. Well, in this, no results is fine. It might be not present in this documentation, but if you look at, if you Google the Crane RStudio.crane project, you will be able to find the Gapminder library. Similarly, you can search for other packages, that is question mark and tidyverse, for example. That's already present over here, so you will be able to get the information about it on the right hand. It's present in the RStudio, so it's documented. You will be able to get the information about it, what it is, and what are the different useful links which you can go through to use those packages. And there's also a GitHub link which is present. Well, moving forward, any questions so far? I know it's a little, it's a little complicated. I don't know. It's it's boring, but how are we doing so far? Okay, I can see no. So next is basically since the first. When you want to import your data set, you will be able to see the data type as numeric data, but you can convert to any type of a data data type, which is numeric character. You can use the as dot factor. As dot factor is basically whichever data type you're going to convert to. So this is basically this is your data name. The $ is you're going to access particular column of your data. So the last column name is the fetal health, if you remember, which is the target column. And I'm using as dot factor function to convert it into a factor data type. So obviously this will not be visible right here. You can use again to conform. You can use the structure function which we used earlier. You will be able to see the change. So over here, so these are the different. I have created a common data types list, and it is well, there are different data types which are present in R, but the common data types are these are the different data types. Logical is all the values which are like true and false value. Numeric is again the values which are part of the integer as well as real numbers, complex numbers. They're all present in case of numeric. And the way to convert it, again, using as dot, the name of the data type you're going to convert to. Again, integer, as dot integer. So all kind of long, short integers are present, and character and as dot factor. Factor is the main when you're working with numerical data, categorical column. So by that I means, for example, if you are having a column which is basically has a gender column, which is like female, male, and so that you can convert it into different levels. Different categories. So you can relabel it as 1, 0. So for that, you have to use, again, the factor. You have to first convert into factor if it is not present. You can use the factor. C over here is the combine function, which you can use. Over here, I've mentioned that basically it helps you create a vector like this. So you can use that to access the vector. Then you can use the factor function, and then the number of levels will help you tell what are the different categories which are present. That is 1 and 2 in this case. This we have looked in detail. Well, I have a picture. Yeah. So in fetal health earlier when I imported, so it was in a numerical format. So it was necessary to convert it into a factor format using as dot factor. Yeah, so these are different methods. Actually, there are more than 2 ways. You can, when you get familiar with R, when you start basic with the R, you can use all those as dot factor, as underscore factor. These are basic conversion methods. But as you move forward, when you try to reduce your coding or reduce the time or make it like optimally well, then you can use the pipe functions. This is the pipe function. This is basically in this, you do not have to write the data every time. Like in this case, it's fine because you're converting one column. But if you want to convert the whole different types of columns, you can write your name, data name, and then pipe function. And this is the mutate function. Now, mutate function is it is the part of the tidyverse library. So you have to install that package. You have to load that package, and then you can finally use the mutate function. Mutate function is the one function which helps you create new columns. In this case, I'm not creating any new column, but just so you know that new columns, as in you have a different calculation. For example, you are creating an aggregate column, like you are creating a percentage of the total sales, or maybe the profit column. Then you can use the mutate function. In that, when you're creating new columns, is that mutate function, name of your column, the new column name which you're going to give, for example, the profit percentage. And then again, in this case, it's converting into factors. So I'm not going to write over here. I'm going to, rather, if I'm creating a profit column, I'm going to give the formula over here. That is the total sales minus the current sale and all that profit formula. So that will help me create a new column in my data set. Again, but in this case, we are just converting into different factors. So you can use that function as well. Yep. So just to keep in mind when you're installing the package, make sure that your this is a case sensitive. The packages R is a case sensitive, so you cannot use this kind of all uppercase or the sentence case. You have to always use the lowercase and make sure that it's always in quote, single or double, doesn't matter, but should be in the quotes. So now, after seeing what you have imported, what is the basic, exploring of the data set, maybe by creating graphs, which you can, I don't know what the time is. Okay, we still have, you can visualize the data set. You can see that what are the basic, using the box plot, using the basic bar charts. After seeing that, then you need to know what are the different columns or what are the different variable types in your data set. So that is very important. So why it is important that if you're creating a model, so if you have what kind of columns what values in your columns are present, like in our case, 1, 2, 3, 1, 2, 3 is present. That is basically a discrete column. It will come. It is not a continuous. Continuous values are all 1.2, 1.3, 1.4. All those kind of values are the continuous values. Now, the last column, that is 1, 2, 3, which is the fetal health column, comes under, if you further categorize, it comes under the category column. So that is why we convert it into a factor. Otherwise, we also have the integer, that is 120 baseline dot value. If you see, that's a integer value. In continuous, we also have that category, but that will be under continuous. Now, under this categorical, we do have further categories. That is ordinal if you have ranking in your column, or nominal or binary. In our case, it's we can do categorize our last column as binary, but again, it also has the third class, which is why we cannot say binary, but we can do say a categorical data, a categorical column. And also, I have written columns / features. All your different columns, they're also known as features. They're also known as columns, so that's why the features. And the last column, which you're creating for the classification model, it's the target. Now, this is the descriptive stats of your data, which is basically why you do this. It's using the summary function, summary, name of your data set. Why you do this is it helps you, first thing, it helps you give the overview of your data variable types, which we did in the last case. So what are the different, this is not clear, but you'll be able to run in your RStudio. Second thing, it helps to check the skewness in your data set. Now, what is skewness? Skewness is basically your data set is, I have a quick picture of it. So this is the skewness of your data set. So normally your data, ideally, it's never the ideal case. Your mean, mod, and median should be in center. So it should not, that means if it is not in center, that means it's not normalized data set. If your data set is not normalized, it can either be a negative skewness, that is more towards the left side, which means that your mean is lesser than the median or the mod, which you can easily see through this. You will have all these categories. In this, you have median, mean, and mod. You can see that in this case, it is one roughly, it's barely visible, but I'll just, okay. So if you look at the first column, the baseline dot values, we have the minimum value, which is 196. The first quadrant, that is 25% of your data, is 120 and 126, the median, and 123, and the mean is. So in this case, we are not having any skewness because this is the idle data, which is 133 and 133, which is kind of nearby. It's not much of a difference, but if you see in this data set, it is mostly a standardized data set or normalized data set. So in this, we are not having the skewness. But if your mean is lesser than the median or the maximum, which is the mod, you will be having the skewness, left skewness. Your data is more towards the negative values. If your mean is much more bigger than the median or your mod values, then your data is more towards the right-hand side. That is positive skewness. Well, a question that can come here is that why do we care about skewness? Again, that's a good question because it depends on your business problem again. So if I talk about in case of an economics problem, then in that case, if you're a small investor, then you might have to disregard the skewness in your data set because initially your investment will be lesser and your profits will be less. But if you're big companies like any of the Google, etc., so you will have a good profits. So in that case, your skewness will be definitely considered because you don't want your data to be more towards the right, more towards the profit side. You do want to see what is your negative side, what are your losses, but what are your profits. So that all can be seen. And again, further, it can be standardized. I have not standardized in this case. We did not require it, so I've not used a method over here. Then finally, so after skewness also helps in checking the outliers. Outliers is basically if your data set is more towards positive side. So for example, if you're having your employees database, which is having different salaries like 10, 20, 30, and one person is having $1,000, that means that is the outlier. So if your data is more towards the right-hand side, so 1,000 is the outlier. You need to take that out, otherwise your results will not be good. That is, your model cannot be, model will not be good, great enough. And there are different ways you can see the outliers. Again, using the box plot, detecting. So I have created. So this is the box plot, which I mean, this is the way where you can plot your box plot. First is again the ggplot library, which is the part of the tidyverse package. The name of your data. In this case, it's a subset data. Let me just quickly run this, otherwise it won't work. Okay, I'll just let you know what I'm doing here is I'm creating a subset of the data. That is, I'm just considering the first 11 columns and not the columns, not the other columns, just to quickly work on the, I mean, just to work on a part of the data set. And also there are different ways where you can do the feature selection as well. That gets more complicated. Because feature selection is necessary, you should know which columns you're going to use for creating of your model. I have included that when you're going to go through this script, you will see there are feature selection method also present. So, and the last column is again the name of the column. So this is basically the subset function I've used and the name of the data set. And again, 1 to 11 column, and the 22 column is the last column. So this is the way of numbering in case of your R. So in case of R, normally all the column numbers start from 1. Otherwise, in case of other programming language, it starts from 0. So I'll just I just have 3 minutes. Sorry. Okay. Well then, I'll just quickly go through my presentation. Okay, so yeah, this was what I was talking about. These are the different feature selection methods which you can follow when you are creating the models. Feature selection is basically, these are the variables. Now this is the method which is the recursive feature elimination method, RFE method in short, or the learning vector queue method. You will be able to access the coding in the R script. Now this helps you to decide which of these columns you can use to create a model. So these are the, you will be able to create this chart. So in this case, for example, you can use the first 4 columns and you can disregard first 4 columns or the first 6 columns because they are closer. I would not use the 6th column. All of these are closer to each other. So these columns can be used. And also this is another method where you will see the different, so since we have different categories, X1, X2, so they have different rankings, you can look for that. Again, the last method, after cleaning up and everything, you can go through the script I was not able to complete. Well, the last is the model creation. Here you should know which algorithm you're going to use for your model. Algorithm as in random forest, what SVM, support vector machine, etc., etc. And then how do you create a model is basically you need to convert it into a test and train and test data. That is always the percentage of 75 or 35, 80 to 20 or 70 to 30. Then you have to apply the model, which are already created for your ease. You just have to load the libraries. And mainly the library which I have used is the Caret library. You'll be able to see in the R script, and then you have to fit the model and lastly check the model performance. Well, I think I'm going to stop right here. I'm taking a lot of time. Any questions? I know you have a lot in a plate, but yeah, anything you would like to say by the virtual audience? Any?
Is there a way they can reach out to you?
Yeah, so I have mentioned at the end of the slide, I have mentioned my email. Also at the beginning of this slide, I have mentioned my email, which is linked, it's embedded in the slide. And also my LinkedIn is present. So my number, everything is present on, phone number is present on that. You can reach me out in case if you need any help. I hope this was a little complicated, and I'm sorry for the technical and me coming late. Nice having you all here, and I hope it was helpful. Thank you so much. Thank you. Bye-bye. Thank you. You too. Thank you.
Pretty close? Oh, yeah, okay.